sometimes circuits are shown Thevenin representation, even though that's not, or Norton representation, even though that's not what you might build. Now you might bias a BJT circuit, something like this, so you don't have to worry about what this BJT amplifier does or how it works right now. We'll get to that eventually, but I just want you to concentrate on the bias network itself, and we might have VCC up here, and we've got an output here maybe to a load, and see, I wonder if there's a way I can change color. That's not what I want. There it is. So we might have RC and RE and RL for the load, and we might have an output there. All of this we'll get to eventually. We have a bias network here with R1 and R2, and it's feeding the base. The terminals are named base, collector, and emitter for a BJT. All of that doesn't really matter at this point. What I'm really interested in you getting a feel for is how this network here, that was interesting, might be represented, and what it might mean. So this is how you might actually build it. So you might actually build this circuit just like this, with this this bias network here of R1 and R2 to produce some kind of voltage at the base here, right there, VB. That's what might, you could easily build it that way. But if you look on a data sheet or some instructions, they may not tell you that that's what it is. They might give you something more like this. I'll give you a circuit that looks like this, where we have these same components, and we have, again, we have RL, and we have V out, and we have VCC up here, and we have RC and RE, and we have now on the base, we still have a base collector and emitter, but now that was not what I wanted it to do. I don't know how I did that. Just erase that. Two fingers. Okay. Base, collector, and emitter, we still have that just like we had in that original circuit, but now we have these two new things, and we might call this voltage supply here VBB, and this resistor might be called RB. It's nothing but a Thevenin representation of this other circuit that we already did, or I showed you. The circuit on the left is how you might actually build it. Over here is how you might actually build it, but here is what you might be given on a data sheet or set of instructions. This Thevenin circuit here might be what you're told to build, and you wouldn't actually build that. You wouldn't actually get a power supply and set up a resistor with that resistance, although I suppose you could. You would actually set it up with a single power supply like here, and two resistors instead of one resistor. So that's what you would actually do, but they might tell you that in this other way. So what does that really mean? That means that we have this, again, this circuit, and this is in a lot of ways the easier thing. We've got R1 and R2. That's just a voltage divider. But we need to solve it, and so we need to find out the resistance of those. So if I draw it instead a bit more like this, so that it looks more familiar to you. And so we've got a VB here, and a VB here. We've got VCC and R1 and R2. Now that looks maybe like something. Okay, why isn't that showing up on the screen? I have to go to page 2 over here too. Okay, interesting. So we have, if we look at the original circuit, we could represent this divider network from VCC down to the base. We could represent it as this divider network VCC R1, R2 to VB, but I could redraw it like this, and you should be familiar with that, and that should feel comfortable at home, and then a comfortable homey kind of place for you, and remember what we're trying to do, or what we do. The first step to solve the resistance is we open up that voltage source to find the resistance. To open it up means we turn it into a short. So I'll just make it a short. R1 and R2, and that's a short. VCC has been shorted. And once I do that, you can see that those two are in parallel. If you can't see that quite clearly, I could move this resistor over here and move this one, the other one up kind of in parallel too, and then it'll be obvious maybe. So let me just redraw it that way. I could move R1 around. So now we have R1 here, and R2 is there. And they're both going to ground. And then we have these terminals, and this one is VB. So maybe that isn't obvious, but we've got VB. I wish there was a pointer I could figure out how to use. We've got VB up here, and that's the same VB as here. I moved, let me mark R1 and R2. We got R1 and R2. So we still have ground. Got ground here connected to one side of R2 and the other side of R2. We have VB connected between R2 and R1, and that's where VB is. So it's really completely the same circuit. You've got to be able to see that and realize it when it's redrawn that way. And with those in parallel, we just know that we could represent those two as a single resistance. RB is equal to the equivalent resistance, which is R1 parallel with R2. So that's easy, I hope. And then we also need this voltage. Well, VB, that voltage there, would just be from the voltage divider. So we need to find this voltage, and that's just a voltage divider. Well, you can see it here. It's a voltage divider from VCC, R1 over and R2, the divider of those two. So let me just write in that equation. So we've got VB, or VB is equal to R2 over R1 plus R2 times VCC. And so I could redraw a circuit, and I would call it VBB now, because we just usually use two letters. And that becomes the same circuit. We have V out, RL, RE, RC, VCC, RB, and VBB. And VBB is equal to R2 over R2 plus R1 times VCC was that, and RB is equal to R1 parallel to R2 from that original circuit. That is how we could solve that, and if we redrew it, we could redraw it like this. So that I think I want that hand there. We could draw it so that we have VBB feeding RB into this base. It's exactly the same circuit. It's just easier and quicker to draw. It doesn't force you to understand how the circuit was really made. You have great flexibility to make it. You just need to build a circuit that will achieve this. But you might actually draw it, make it into a circuit like that. So I'll give a short example after this, and you can work on that.